So this is a cycle. Basically, our zeroth index will point to one index, and our one index then point to 3th index. Then our 3th index will point to second index. Second index will point to fourth index, and fourth index will again point to second index. So basically, we have a cycle here. This is our cycle. Okay, let's take another example. Below array, I'm writing indexes: zeroth index, one, second index, third index, and fourth index. So my zeroth index will point to three index, and my three index will point to mm, fourth index. My fourth index will point to mm, fourth index will point to fourth index will point to second index, and my second index will point to third index. Okay, so this is a cycle basically. Then my third index will again point to fourth index, and fourth index will point to second index. So basically, this is a cycle. This is a cycle of which cycle is existing here. Zeroth index will point into third index. Third index is pointing to fourth index. Fourth index is pointing to second index, and second index is pointing to third index. So third index again pointing to fourth index. So basically, this is a cycle. Second index pointing to third index. So this is a cycle. After this, the elements will repeat. Means my second will point to third. So basically, this is a linked list with where the cycle exists, and to find the head of the cycle, we use uh, the hare and tortoise approach, where we use slow and fast pointers, and wherever the pointers meet, that position is the head of the linked list. So optimized approach which we hire an and tortoise approach. Okay, so let's implement this approach. Uh, let's say our int slow pointer is at nums of 0 index, and our fast pointer is at nums of nums and 0 index. So while our slow pointer is not equal to fast pointer, so we are sure that uh, there is only one repeated number, so that our cycle will exist. So because there is a repeated number, so while our slow is not equal to fast, we will move our slow to nums of slow, and fast to nums of fast. So basically we are moving two pointers ahead. uh, at the end we can return slow pointer. Let's try running this. Okay, so we have got 4 here, this second element of the cycle. Here we have got 2. Mm, okay, so I think we have what we are doing here. So initially my nums of 0 is 1. Okay, and nums of 0 means nums of 1 is 3, so I am starting from 1 and 3. Okay, so I move my slow pointer to here and fast pointer to uh, 3. Nums of 3 is 2, and nums of 2 is 4. Okay, let's print slow and fast pointers. Okay, so my slow pointer is 3, then my fast pointer is 4, then my slow pointer is 2, my fast pointer is okay. So in order to find the head, we need to reset our slow pointer. So let's reset my slow pointer. While slow pointer is not equal to my fast pointer, I will move both by mm, nums of slow fast as the nums of fast. Okay. Mhm. I think I am missing something. Let's see. Sorry. Let's see previous submissions. I think the first submission was also using fast and slow pointer. Why I'm taking zero here? Didn't understand. Zero because I think my list starting is from zero maybe. I think this will work. There's, I think there is a proof of this question in a book, cracking the coding interview. Cracking the coding interview. I think I have it on my device. Cracking the coding interview. Okay, so let's search linked list. Linked. Okay, so these are the link lists. So I think here we have loop detection. Given a circular linked list, implement an algorithm that returns the node at the beginning of the loop. So this is the same question I think we have. Definition circular linked list. So we need to find answer to this problem. So hint start on page 653. We need answer to linked list part. So let's see index where are answers. Hints 652 page. Okay, we need hint for part. Hints, concepts, and algorithms. I forgot what question we were on to. Loop detection. So we need a solution. Okay, so this is the problem loop detection. This is a modification of classic interview detective linked list as a loop. Let's apply the pattern matching problem. Detect if a linked list has a loop. An easy way to detect a loop is through slow. I think my screen is visible. Okay, so is through fast and slow runner approach. Fast runner moves two step at a time. Slow runner moves one step. Much like two cars racing around a track at different step, they must eventually meet. Uh, Now we will discuss the condition when the both the fast runner and slow runner meet. That's not possible. Suppose the fast runner did hop over slow runner such that the slow runner is spot at I and fast runner at spot I plus 1 in the previous step. The slow runner would be at stop I minus 1 and fast runner would be at spot I plus 1 minus 2. Okay, so let's say this is a loop. This is odd part, even part. Let's now suppose the fast runner did hop over slow runner such that the slow runner is a spot I. Suppose slow runner is I and fast runner at support. Fast runner, slow runner. Slow runner I, fast runner I plus 1. In the previous step, slow runner would runner would be at spot I minus 1. Okay. Fast runner would be at sub I plus 1 or spot that they would have collided. Okay. Hmm. When did they collide? Let's assume that the linked list has a known loop parts of size k. If we apply our algorithm from part 1, when will start fast runner and slow runner collide, we know that for every p steps that slow runner take, fast runner takes 2p steps. Therefore, the slow runner enter the looped portion after k steps. Okay, fast runner has taken 2k steps in total and must be at 2k minus k or k steps into the loop portion. Since k might be much larger than the loop length, we should actually write mod of k loop size step, which we denote as k. Okay, at each subsequent step, fast runner and slow runner get either one step farther away or one step closer depending on your perspective. This is because we are in a circle. When A moves Q steps away from B, it is moving closer Q step closer to B. So now we know the following facts. Slow runner is 0 steps into the loop. Fast runner is K steps into the loop. Okay. Slow runner is K step behind fast runner. Okay. Fast runner is behind. Okay. Slow runner. Fast runner catches up to slow runner at the rate 1 step per unit of time. Okay. So when they actually meet, well, fast runner is behind slow runner and fast runner catches up at the rate per unit time. Then they meet after loop k minus k steps. At this point, they will be before the k steps before the head of the loop. One, two, three, four. Do you know? Do you find the start of the loop? We know collisions. How do you find the start of the loop? We know collision spot is k nodes before the start of the loop. One, two, three, four, 2, 3. For example, if node n, therefore the collisions for an linked list head. ओके, तो सिंपली बात ये है कि जो हमारे स्लो और फास्ट पॉइंटर यहाँ मिलेंगे, तो जहाँ वो मिलेंगे वो इस हेड से उतना ही दूर होगा, लूप के हेड से, जितना ये बाहर वाला जो सर्कुलर पार्ट में जो नहीं है। जैसे 1, 2, 3, 4 नोड है यहाँ पे, तो 4 ही यहाँ पे होंगी, 1, 2, 3 एंड 4। सो दैट्स द कॉन्सेप्ट टू फाइंड द हेड ऑफ द लूप। Okay, now moving to the next problem, LRU cache. This is the very famous interview problem, so let's implement this also. I am having a headache, guys. Design a data structure that follows the constraints of a least recently used LRU cache. Implement LRU cache class. LRU cache in capacity initialize the LRU cache with positive size capacity. Okay. So this is the capacity of our cache. We can also write as okay. Void put int key int value. Update the value of the key if key exists. Let's write out first function int get. Return the value of the key if it exists. Otherwise -1. Okay. Value of the key if it exists. Otherwise -1. Okay. Void put int value. Update the value of the key if key exists. Okay. Otherwise add the update the value of the key if key exists. Otherwise add the key value pair to the cache. Okay. If the key already exists, then we update its value. Otherwise, we will add the key value pair to the cache. If the number of keys exceeds the capacity from this operation, evict the least recently used key. Okay, the function get and put must run in big of one average time complexity. Update the value of the key if it exists. Otherwise, add the key value pair to cache. Okay. So we need to maintain only five keys. Sorry, if capacity is five, suppose capacity is five, then we only need to maintain uh, five keys in the data structure which we'll be using. Okay, and get function will check if key is present. If our key is present, then we'll return its value. Okay, otherwise we will return -1. So this is giving me a feeling of using some kind of hash map where we can store the key and value corresponding to it, and we can check our hash map whether the value is present in hash map or not. If it is present, we can return the value. Otherwise we can return -1. So yeah, so we can use a hash map for this operation. Then we have another function, put. So what put will gonna do, it will gonna update the value of the key. Okay, if it exists. So if our key is already exists, then it will not use our capacity part. So in that case, we don't need to check whether our capacity is increasing, means we are getting out of capacity. Okay, so otherwise, if key is not present, we will add the key value pair to the cache. Okay, we will add that key value pair to the cache. Okay, if the number of keys exceeds the capacity from this operation, evict the least recently used keys. Okay, so in update operation also, suppose I have a key 1 and 4, then I add key 2 and 3. Now I need to put 1 and 3. So, and my capacity is, let's say, 3. Okay. Now we need to add key 1 and 2. So 1 already exists, so in that case we need to add it to our what we say means this after update operation this becomes recently added, so this will become 1 and 2. And after that if we add 3 and 4, let's say our capacity is 2, so this will get out of capacity, so we will remove this key. Okay. And we will remove it from map also. Mm. So I think something we can use a map to store a key, and to store value we can store a node, uh, and in order to maintain a cache we need some data structure where we can remove last element, and also in update operation we can delete a node and put a node in front, delete and putting in front. Okay. So I think we can use a doubly linked list here, and we can also use a linked hash map, which is also based on doubly linked list in Java, and that will also play a role of both, means doubly linked list and hash map, means combination of hash map and doubly linked list is uh, linked list, linked hash map. So public class double list int value double list next double list previous, and a constructor which will take value, and will initialize this dot value as value, and next as null, and also previous as null. Okay. So now we have a doubly linked list class. We can also add multiple functions to it. Okay, let's initialize our doubly linked list. Uh, I think we should put a dummy value. Let's see. Okay, so I all values are positive. Let's put -1 here. So I initialize my doubly linked list, and also I need a hash map to store that integer value and that list's reference. Okay. Okay. So whenever we see a get operation, we will check if our map contains that key. Map contains key, which key. If it contains, we will return what we will return. We will return map dot get. We get this linked list, and wait a second. We will return this linked list, and we will return this value dot value. Okay. Now after if now we have two options: if our key exists or our key value doesn't exist. First part will be if our map contains key, that means we need to update the value and our capacity will remain same. Otherwise we will need to add that and need to increment our capacity and need to check sorry suppose we decrement our capacity and we check if our capacity is reached 0. In that case we will remove least recently used cache. So if our map contains that key, so we need to find the address of that list. So Address of that list will be what we call, let's say, node map.get key. So basically this will be the address of our node. Okay, so what we need to do is we need to detach that node from that position, and we need to add it to the start of the list. Okay, so how we will gonna remove that list? So we will find previous of that node dot previous. Okay, every node will have a previous, that is my dummy node. Okay, I will check that previous part. Okay, let's, this will be the tail of our node, this dummy list. I think I should create a function which will remove a dummy node from the list, means that will do something like list dot remove node. Okay, after removal of node, I need to add a new add at start, list dot add a new double list. I can put same node at the start, or also can put a new different node. I'm feeling sleepy, guys. With the value Okay, we need to remove in that case. Otherwise, we will be adding a. Okay, we will be adding a list. Mm, we will be decrementing the capacity. Okay, so we need to remove public void remove. Okay, so remove function will take a node's address. Basically, this node will be कॉपीराइट हो जाएगा नहीं, हटा दिया करी न्यू स्ट्रीम गानों चलाओ जी माँ के जो इसी की मैं बता
सही है नहीं, ये एन को डिफॉल्ट आलो सुधर लगा सही लगे
की कर दियो
कि मैंने बस न्यू दिखा वो
यूजर नेम और वो के
हाँ सारी चीजें तो ऐप फोटो पे क्लिक करके सीधे अपलोड करवा दे न्यू
वह क्या को है वेंडर को कि यूजर को है
वेंडर को
सही है
और किना अपलोड अपलोड फोटो फोटो सारो कर दियो बस उन फैच करना है डाउनलोड करना होगा ये तो नहीं शायद चैट जीपीटी को लिखवा दी कार्ड का
फॉन्ट मस्त है इसका है ना
किसका
एक्स कोड वाला एप्पल वाला
हाँ मतलब यार एंड और हम कंफ्यूजन हो जाए हम कंफ्यूज को नो बेरो को मन काम कर दें लगे है और ये जिस और डिटेल फिल करो तो सारी आ जाएंगी इसमें
सही लगा मुझे तो
अरे ये न्यू जो डिफॉल्ट यूआई एंड्रॉइड को दी है वो भी एंड्रॉइड वालों भी डिफॉल्ट यूज कर लिया न्यारो कौन बनावा समझ गए जो डिफॉल्ट थी गाड़ी की डाल है वो यूज कर लिया जैसा ये डिफॉल्ट नहीं है एप्पल का खुद का
Can our capacity assist? Hello.